So good evening to one and all. So welcome to ACE Engineering Academy as well as ACE Online. So the main purpose of conducting today's session is, we know that ACE Engineering Academy is providing a PYQ series with respect to ISRO examination to help the all ISRO examination aspirants. So as part of that, today we are going to see the discussion about the previous year gate questions, previous year ISRO questions related to a subject called computer networks. So this is what our agenda. So as ACE Engineering Academy is providing you a series of ISRO PYQ sessions. As part of that, today we are starting this session, right? So I hope you are all doing well with respect to your ISRO examination preparation as well as your GATE examination preparation, right? So first of all, this is Venkateshwarlu, myself working as an associate professor in CSE department of ACE Engineering Academy, and my expertise subjects with respect to GATE examination is computer networks as well as operating system, and these are the credentials of my educational related. And this is already, this particular weightage with respect to every year and with respect to every subject, this weightage is been already discussed in our previous sessions by my colleague Ramesh Garu. So as part of that, if you can see specifically this particular part, computer networks and security part, which is having highest weightage throughout this ISRO examination. Whatever the history of ISRO examination you can see from 2007 to 2023, we are having around 132 questions. And latest in 2023, you can see the weightage of this subject is 11 questions, which is highest among all the subjects of, you can say, with respect to technical, right? So that is what I have showcased you with respect to 2023. Computer networks is having highest weightage, right? So with respect to this ISRO examination, what are the topics that we need to focus in connection with this computer network subject? That is what we have to know first. So for that, if you can see this pie chart, I can say the basic syllabus which you have to focus on is, these are the contents. Like you can see, data link layer is one content, network layer is one content, or else you can say topic, transport layer is another topic, and concept of layering is another topic, information security is another topic, and some miscellaneous topics also we need to concentrate here. So all these 132 questions previously, whatever I have showcased you, are being distributed at maximum per topic like this. So from data link layer, you are having 37 questions. From network layer, we are having 39 questions. From transport layer, we are having 10 questions. From concept of layering, we are having 25 questions. And from information security as well as the miscellaneous content, we are having 11 number of questions. So most of the weightage is among these two layers. So among these two layers, you know, your data link layer can do several functions, like it can do framing, right? It can also do error control. It can also do flow control. It can also do access control, right? So these are the major functionalities of your data link layer, along with provision of physical addressing and providing node-to-node delivery. So these are the functions that can be done by data link layer. We are having questions from framing also, like one question, there is a concept called bit stuffing. Based on bit stuffing, we are having 1 or 2 times of previous year ISRO questions. And from error control also we are having questions. From flow control also we are having questions. From access control, we are having questions. Specifically, if you consider error control, we are having questions from CRC. We are having questions from parity check, two-dimensional parity check. So you can say simple parity check and two-dimensional parity check and checksum related to these topics or as these subtopics, we are having some questions. From framing, we are having questions. You know, there is a topic called bit stuffing. Based on this bit stuffing, we are having some questions. And if you consider flow control, we are having questions from both stop and wait and sliding window protocol. And coming to the access control, we are having questions from Aloha as well as CSMSCD. So all the topics, these topics generally we used to cover with respect to GATE examination also. Almost the same kind of syllabus, if I can say here. So if you prepare well for the GATE examination, ISRO examination, you can easily clear, right? So because the content is same, the syllabus is almost same. Nowhere it is clearly mentioned, but of course, according to the previous history, we can say that these are the subtopics with respect to every layer on which you have to focus. Then coming to network layer, if you consider, we are having questions on routing concept. We are having questions from IPv4 addressing. We are having questions from fragmentation and reassembly, right? So these are the main topics from where we got the questions in our previous ISRO papers with respect to this network layer. And coming to the transport layer, we are having questions from, you know, connection management. We are having questions from TCP timer management, right? We are having questions from three-way handshaking and etc. So these are the major topics that you have to focus with respect to transport layer. And then coming to concept of layering, what are the topics that you have to focus here? Concept of layering in the sense here our intention is to discuss about ISO OSI reference model and TCP IP reference model. And you know, as part of ISO OSI reference model, we used to cover the functions of every layer, right? As well as in the TCP IP reference model, we used to cover all the protocols functionalities. So based on that, we are having previous year ISRO questions. And then coming to the information security, you know that we are having some symmetric key cryptography, asymmetric key cryptography, this kind of stuff is there. So based on that, we can also have question. We also had some questions in our previous year papers. And coming to that miscellaneous, it is like we are having some IEEE standards. Based on the IEEE standards and their respective data speeds, we are having previous year questions also. So these kind of topics that you need to focus with respect to this computer networks part. Okay, so now I am going to show you the weightage. I mean, by considering all these number of questions per layer, this is what the pie chart which I have done. Like majority of the content is from data link layer and network layer. So if we cover this data link layer and network layer thoroughly, nothing new here, only the GATE, with respect to GATE, what we have learned, what we have studied with respect to this data link layer and network layer, that portion is enough even to attend this ISRO examination. Okay, so majority of the content is from, majority of the previous year questions are from these two layers only. Okay, so that is what the conclusion from this slide I can tell you. So as part of this session, what I am going to cover, the latest 2023 ISRO questions we are going to discuss. So as part of that, so that is what I just told you. So the main intention of today's session is to have a discussion about the previous year papers, previous year questions, and latest, like in 2023, ISRO is conducted some examination. So from that particular paper, from computer networks, we have 11 questions. Those 11 questions discussion we are going to see, along with 2020 questions also we can see. Okay, so as part of that, first if you can check this question. So if you people are live, if you are part of the live session, please go through this question statement and let me know what is the answer. In the meanwhile, I also can solve this question so that we can answer to this question at a time, right? So try to go through this question and let me know what is the answer. So in the meanwhile, I also can solve this question. So the question is clearly mentioned. We are using some CSMA CD network, and the minimum frame size is being given as 1500 bytes. And the question is asking you what will be the data transfer speed. It means it is speaking about the bandwidth. We need to find out the bandwidth over a 1 kilometer cable, which is distance is being given, and the speed of propagation is also being given, which is 250,000 kilometers per second. So you know that in CSMA CD, so first of all, let me collect the data, whatever the data that is being given. So distance is being given 1 kilometer. Propagation speed is given 250,000, which I can also write as 25 into, so 10 power 7. I have converted this kilometers into meters. So this is also, if I convert this into kilometers into meters, 10 power 3 meters, right? And this is 25 into 10 power 4 into 10 power 3, which is 10 power 7 meters. Okay, so then along with this, the frame size is also given. What is that? 1500 bytes. And it is asking you to find out bandwidth. So I hope you people are solving this question, right? So we all know that in CSMA CD, to detect the collision, the minimum frame size is being given as 2 into TP into bandwidth, right? So here we need to find out the bandwidth. L is been given already, 1500 bytes. But if you check options, all are in terms of bits. So that's why I just converting into bits. So which I can write as 1500 into 8 is greater than 2 into TP. So from these two, I can calculate the TP. What is the TP? Which is D by V. That is equals to 10 power 3 by 2 into 10 power 25 into 10 power 4 into 10 power 3. So like this we can write, right? So now TP, if I want to express in terms of microseconds. So here the question, it is asking about everything is in terms of gigabits per second. If you consider, most of the options are in terms of gigabits per second. So here, how can I write this one? Like this is 10 power 3, this is 10 power 4 and 10 power 7. So this is overall, this is 10 power 7, okay? So then this I can write as 10 square into 10 by 25, or else 10 power 3, I can keep it is 10 power 3. So 10 power 3, which is 1000 into 250 I can write, okay, 250 10 square. I mean 10 power 6 I can write, 250 into 10 power 6, right? So then this cancel, and 25, 4, I can write it is 4 microseconds, correct? So 4 microseconds I can write here. So that is what my TP. So here L is what? 1500 into 8. So 2 into 4 microseconds into bandwidth. Okay, so then I have to find out the bandwidth here, right? So to find out the bandwidth, what should I do? So for example, if you consider L by, you can say this 2 into 4, which is 8 microseconds I can write. 8 microseconds I can write. Okay. So then what is the L? 1500 into 8. What is that 1508? If you check 1508, if you check 1500 into 8, you can have 12,000, right? So this is 12,000 by 8 into 10 power minus 6 I can write, right? 10 power minus 6. Then this you can write as bandwidth is equals to, this obviously I can write it is in terms of what? 10 power minus 6 if I go, so I am having 12 by 8 into 10 power 9. So this is what my gigabits, right? So 12 by 8, if I do 12 by 8, I am getting 1.5 Gbps. So 1.5 Gbps is the answer that is matching with option D. So I hope all of you got the same answer, right? Right. So let us move to the next question. So this is direct question, right? So we are having several questions based on the CSMSCD even in our gate papers. So if you do practice, easily you can able to solve this question, right? So instead of considering here L is greater than or equals to 2 into Tp into bandwidth, you just consider this one as L is equals to, you can consider it as L is equals to 2 into Tp into bandwidth. Then you can see the expression can be easy to you. Okay, so now the expression can be easily solvable. So 1500 into 8 by 8 into 10 power 6. Like that we can write. Okay, so this is what the solution for this question. I hope you are clear with this. Yeah, so I can see that there are some students are given correct answer, right? So let us move to the next question. So look at this question. So for internal data communication through computer network, a 5-layer protocol hierarchy is proposed. Applications to be used in the network generate 270 bytes long messages. At each of the layer, a 6-byte header is being added. What fraction of network bandwidth in percentage, we need to express in terms of percentage, is wasted due to the header? Okay. So this kind of questions, we know that as part of our gate papers also, we have solved this kind of questions, right? So verify. So if you consider, it is clearly mentioned 5-layered protocol. It means at the center system, you can have layer 5, layer 4, layer 3, layer 2, layer 1. And when you have a message, what is the size of the message here? 270 bytes of message. So when you have some message, first to this message, you are appending L5 header, and then this L5 and M is being encapsulated into L4 PDU, right? So now this is what your L5 PDU, to which we have added L4 header. And similarly, this is the L4 PDU, and this L4 PDU, to this L4 PDU, we are appending L3 header, and this L4 PDU is going to act as SDU as part of L3 PDU. So this way, at every layer we are appending the header. So what is the size of the header? The question is given. 6 bytes of header is being added. How many layers we are having? 5 layers. So that 5 headers can be added. So 5 into 6 bytes, which is 30 bytes of header we are adding to the message. So what is the size of the message here? 270 bytes. So 270 bytes is the message, right? 270 bytes is the message. Message is 270 bytes. And header is 30 bytes. Then now what you are going to do, onto the channel, you are placing all these 5 headers plus message you are placing onto the channel. So which means out of these, so how much amount of message that you are placing? 5H plus M. 5H in the sense 5 into 6 bytes plus M, which is 270, which is you can say 300 bytes. This is the total message that you are placing onto the channel, right? So what fraction of network bandwidth is wasted due to the header? So out of this much 300 bytes, what is actually your burden? Your burden is header only, right? Which is 30 bytes. So then bytes cancel, which is coming to 1 by 10, which you can write as 10%. So 10% is the answer for this question, which is option C. So I hope you people are also got the same answer, right? So this is what the explanation for this question. So these kind of questions are there in our ACE material, right? As well as we have given these kind of questions even in our test series also. So I hope you are clear with this question and the respective explanation and how the key is option C. So can I move to the next question? Okay. So let us move to the next question. So verify this question. This is related to your sliding window size, sliding window protocol, correct? So look at the question. A host in one organization is connected to another host in other organization using 1 Gbps link with 25 milliseconds of RTT. Network administrator of this network tuned the packet size to 1000 bytes to transfer large files optimally over the network. In order to have channel utilization greater than 96%, how big the window size in terms of packets should be, assuming that the acknowledgement packets have no impact. So window size we have to find out. So what are the things that is been given? Bandwidth is been given 1 Gbps, right? So bandwidth is given 1 Gbps. RTT is given 25 milliseconds, okay? And packet size is given, which is 1000 bytes. And efficiency is given, it has to be more than 96%. It has to be more than 96%. Right. So here from L and B we can calculate Tx. So Tx is equals to L by B, which is 8 into 1000 by 10 power 6. 8 into 1000 by 10 power 6. So as this RTT is in terms of millisecond, better expressed this is also in terms of millisecond. So 10 power 3, 10 power 6 cancel, I can have 10 power 3, right? So what I can write here, so this I can write as 10 power 3 into 10 power 3. Okay, so let me do some small modification here. So instead of writing 10 power 9, so this is 10 power 9, right? So 10 power 9. So 10 power 9, how can I write? 10 power 3 into 10 power 6 I can write. So 10 power 3, 10 power 3 cancel, so that I can write this is 8 microsecond. Okay, so RTT is given in terms of millisecond. So I just want to express this in terms of microsecond. So if I want to express this microsecond, already this is what your 25 milliseconds. Now I want to express this in terms of microsecond. For that I can do this one. So which is 25,000 microseconds. Okay, 25,000 microseconds. Right. So then what I can calculate? I can calculate TP now. So RTT is 25,000 microseconds. Then what is the TP? 25,000 microseconds by 2. So 25,000 microseconds by 2, if you evaluate this expression, so 25,000 by 2, 12,500 microseconds. So now Tx is ready and Tp is ready. What you can calculate? A you can calculate. A is equals to Tp by Tx. Tp is 12,000 microseconds. Tx is 8 microseconds. So 12,500 divided by 8 if I do, I am getting 1562.5. 1562.5, right? So therefore, you know that efficiency formula is what? W by 1 plus 2A. In the sliding window context, the formula for efficiency is W by 1 plus 2A. So efficiency is given as 96%, which is I can write as 0.96, right? So this I can write as 0.96. So 0.96 is equals to W by 1 plus 2 into A. So 1562.5 into 2, 3125, 3126. So this particular one I can write as 3126. So this particular one I can write as 3126. So then W it is asking you to find out. So 3126, correct? So 1562.5, which is to 3125, right? So then 3126 into 0.96. If you do, you are getting 3000.96. So the answer among these options, if you can check with this window size of 3000.96, option C is the answer for this question. So I hope you got this same way and you got the answer as option C, I hope so. Am I correct? Right. So these are the questions that we are having with respect to numerical. Let's see. We are having some other questions based on the theory. So what is the answer for this question? Please let me know. If you are able to give me the answer, please give me the answer. So we need to find out the true statement here, okay? We need to find out the true statement. We need to find out the true statement. So what is the answer for this question? Right. So we need to find out the true statement. Option A, both parity and cyclic redundancy check are error correcting codes. Option B, both parity and low density parity check codes are error correcting codes. Option C, both Reed-Solomon code and the low density parity check code are error correcting codes. Option D, both cyclic redundancy check and low density parity check codes are error correcting codes. See, you recall as part of the data link layer we have covered about error control and we have covered various types of redundancy techniques. So what are the redundancy techniques that we have covered, like simple parity check, two-dimensional parity check, cyclic redundancy check, checksum and Hamming code. So these kind of techniques that we have covered in our sessions, right? Among these, if you can check cyclic redundancy check and parity check, you please recall them. So if you recall, you can easily answer this question. So both cyclic redundancy check and simple parity check are just error detection techniques, but they are not error correction techniques. That is the thin line of key point to answer this question. So here option A, it is saying that both this parity and cyclic redundancy check are error correcting codes. Is it so? No, right? So this parity check and cyclic redundancy check are just detection techniques but not correction techniques. Hence, this statement is false. Next, both parity and low density parity check are error correcting codes, but here it is mentioned parity. But this parity, which is your simple parity check, is just a detection technique but not correction technique. So here it is mentioned that correction technique. No, this is also false. And similarly, if you check with option D, both cyclic redundancy check and the low density parity check codes are error correcting codes. No, your cyclic redundancy check is just a detection technique but not a correction technique. So this is also false. So what else remaining? Option C. So option C is the answer for this question. So directly we can say like this, right? So because you know that your simple parity check and CRC are only detection techniques but not correction techniques. So I hope you are clear with the explanation of this question and you got the same answer. Am I correct? Right. So questions are very simple. I am telling you, questions are very simple in ISRO examination. They are not much tougher than your GATE examination. The preparation that you are doing for GATE examination is enough to crack this ISRO examination according to the standard of the questions from the previous 2007 onwards. So based on that, we can tell that whatever the preparation that you are doing to write GATE examination, that preparation is more than enough to crack this ISRO examination also. Okay, so this is what the discussion about this question. Let's move to the next question. So this is the question from information security. So with respect to GATE, we discuss about only computer networks part, but we don't cover information security part. That is the additional content that you need to prepare with respect to this computer network subject. If you are going for ISRO examination, along with that networking concepts, you need to have an idea on security concepts also. So these kind of questions are possible to ask you. Look at the question. Asymmetric encryption. So basically the meaning of asymmetric, it is what? It is public key cryptography, right? It is public key cryptography. So asymmetric encryption is not suitable for. One is called confidentiality, another one is called authentication, other one is called key exchange, and option D, prevention of denial of service. So please let me know what is the answer for this question, guys. The people who are part of live, please answer to this question. Straight question, very easy. So basically this asymmetric cryptography can give you confidentiality, can ensure authentication, can ensure this key exchange also. For key exchange purpose, for confidentiality purpose, for authentication purpose, we can use this public key cryptography. So, but when it comes to prevention of denial of service, basically what is the meaning of denial of service? DOS attack we used to say, right? What is the meaning of denial of service? Sending floods of duplicate packets to make the network buffer is full. That is what the meaning of denial of service attack. Like if you are conducting some juice business, let's say fruit juice shop you are having. So many people, I will send to your juice shop, like I can send so many people to your juice shop, but they don't buy. What they do, what is this juice cost and how you prepare this, like that they can engage you. So I can send a flood of people to your juice shop. So whenever so many people are there at your juice shop, obviously the people who are actually willing to have the juice, or else actually who are willing to purchase the juice in your juice shop, those people cannot get the scope to come front and asking you to prepare the respective juice. Reason, I have sent multiple people and they are in the completely filling the buffer or else the space that you are having in that fruit juice shop. All these seats are being occupied with those people, and those people are not buying the juice, and they just what they are doing, they are inquiring to you like how you are going to prepare this, what are the elements, what are the ingredients that you are going to have in this. Like that they used to, by having which combination we can get some healthy, which is the healthy recipe or else healthy juice. Like that they can engage with you. So the actual customer is staying away from your business. That is called denial of service attack, making buffer overflow. So here this asymmetric encryption is not suitable. It is not suitable for prevention of denial of service attack. So that is why we can say option D is the answer for this question. Okay? Let's move to the next question. So look at this question. Which of the following is the cause of ping of death issue related to ICMP packets? Option A, buffer overflow. Option B, divided by 0. Option C, missing input sanitization. Option D, privilege escalation. What is the answer for this? So this is related to ICMP packets. You concentrate on this divided by 0. This is related to some program, right? In a program, you may have this kind of flaw, correct? So, but this is not related to your ICMP packet. Hence, option B, you can eliminate. Next, option C, if you can consider missing input sanitization. So, input sanitization, you are missing in the sense it is related to your SQL injection or else some script, cross-site script related issue it is, but not it is related to ICMP packet. So that is why this is not an answer for this question. Then coming to option D, you are having some privilege escalation. Privilege escalation is related to the administration levels. So, but this is not related to ICMP packets. Hence, this is also not an answer for this question. So, what else remaining? Buffer overflow, which is again your denial of service attack. So, this particular ping of death is a cause. It is a cause of ping of death issue. What is that? You can say that the denial of DOS service, DOS attack, denial of service attack. The service is being getting denied, denial of service. Okay? So that is the way how you can define this. So buffer overflow is the answer for this question. So I hope you are following my explanation. Right, let's move to the next question. Look at this question. Which of the following is the context of information security which are closely associated? So look at up to now whatever the questions that we have solved. This is related to network. This is related to security. This is related to network. This is also related to network. This is also related to network, and this is also related to network. So the questions are combination network as well as security we can have. So that's why only preparation of network may not be sufficient. Along with that, a little bit knowledge of security is also needed to attempt computer networks with respect to get ISRO examination. So look at this question. Please let me know what is the answer. Straight questions you can easily identify. You can easily identify what is the answer for this. Please verify what is the answer for this. I can wait for you for a few seconds. Right. So look at this question. You all know that NAT. What is the meaning of NAT? Network address translation, correct? So this NAT, network address translation, what it is doing? It is converting the private IP addresses into public IP addresses and public IP addresses into private IP addresses, right? So which means it is hiding the private IP addresses, correct? So means NAT goes to Q. 3Q, if you can check among the options, it is only in option A. So straight away you can say option A is the answer for this question. Straight away, because among all options, there is no 3Q. Then stateful, I told you, please recall, what is the meaning of stateful? Stateful means buffering, tracking, right? Whatever the conversation details that are happened between the client and server, they get tracked or else they get buffered. That is what stateful. So based on that, you can check, keep track of TCP IP connections, which is 4 goes to R. That is why you can see 4 goes to R. So based on these two, which are known to you, right? You need not to bothering about this ingress filtering and egress filtering. You need not to bother about them. The things which you know, NAT and stateful, based on that, the answer is been A. Simple question, right? So ingress filtering goes to malicious traffic, and egress filtering leads to data leakage prevention. So these are the correct matching between this list 1 and list 2. So I hope you got the answer for this question. So based on just this NAT itself, you can filter all the options, right? So option A is the answer, very simple question. So let's move to the next question now. Look, there is one more matching kind of stuff. This is also very easy to you. Please try to go through it. It is also very easy to you. You can easily answer it. So first, if we consider fingerprinting. Fingerprinting is what actually it is a part of your cyber security, ethical hacking related, in which you are gathering the information, sensitive information. So for fingerprinting, you are using what? This particular thing, that is determining the version and name of the operating system and respective operating system utilities. Fingerprinting goes to 4Q. So if you can see all of the options, 4Q you cannot find in option D, so that option D is eliminated. Next, encryption. You know that encryption. Encryption is what? Converting the plain text into ciphertext. So which means you are protecting the confidentiality. So 1 goes to R. 1 goes to R. But if you check here, option B, it is given 1P. There itself you can eliminate this. So the answer is among A and C. Then you all know that ARP. What is the functionality of this ARP? It is converting your IP address into MAC address. Simple, IP to MAC. Where you can see in the options? Here you can see in the options, which is 3S. But among the options of remaining like A and C, 3P it is given, but not 3P. 3S is correct, right? Because ARP spoofing is related to your IP to MAC. So that is why you can say option A is the answer for this question. So 1R, then fingerprinting, which is 4Q, and then ARP spoofing, which is IP to MAC, which is 3S, and 2P. MAC cloning goes to manipulation of your NIC. So this is a way how you can match. Very simple questions. These are all very simple questions, right? So I hope you got the answer for this question. So based on this MAC, I can filter option C. Okay, based on ARP. Based on ARP, I can filter that option C. And option B got eliminated based on encryption. Based on encryption, option B got eliminated, right? So based on fingerprinting, option D got eliminated. Based on ARP spoofing, option C got eliminated. Only leftover option is option A, so that option A is the answer for this question. So I hope you are clear with this, right? Then coming to next question. So this is also this is called, I told you know, miscellaneous concepts. So these are comes under your miscellaneous concepts. Sometimes questions are maybe out of the box also. So look at that question. So match the following. It means here we are having some wireless versions and their respective speeds. So we need to match those wireless versions with their speeds. So if you can check with 802.11 AC, it is providing you 3.5 Gbps speed. So 1S, if you can see, this is eliminated and this is eliminated. Then 802.11, 11 A by G, this particular one is providing you 54 Mbps of internet speed. So that is why in both options we are having 1S and 2R in both options, right? And then the answer is going to be decided based on third and fourth. So third one is what? 802.11 AD. It is offering you 7 Gbps, but not 11 Mbps. 7 Gbps it is offering. So that is why option A is the answer for it. Here it is given 3Q, which is wrong, right? So these are the speeds. You can say option A is the answer for this question. So I hope you are clear with the explanation of this question. These are standard questions, like no further explanation, because it is speaking about data speeds and corresponding wireless versions. So that is why we don't have much discussion with respect to these kind of questions. These are just direct questions. We need to find out the speeds of every wireless technology. I can say these kind of questions are comes under your miscellaneous, right? So let's move to the next question. So look at this question. Which of the following methods used to detect double errors? One is odd parity, another one is even parity, and option C it is given checksum within brackets CRC, option D checksum within brackets XOR. So if you can check this even parity and odd parity. Even parity and odd parity. So even parity and odd parity, we are able to detect all single bit errors, right? We are able to detect all single bit errors with respect to both even parity or odd parity, or else you can say that parity check, using the simple parity check, we can detect all kinds of single bit errors. But when it comes to double bit errors, or else you can say burst errors, all even numbered burst errors are undetectable, but odd numbered burst errors are detectable. So that is a way how you can say that this is the option A and option C got eliminated. Then if you can check with the CRC, checksum with the CRC, right? So CRC. So this could be the possible answer for this question, option C. So we are using checksum, which is your cyclic redundancy check, that is used to detect the double errors. Okay. So straight question this is also, like we have analysis, we have done some analysis now, like CRC, is it able to do single bit error detection and correction or not? For every redundancy technique we have explained in our classes. Simple parity check can do even, can calculate simple single bit errors or else burst errors. Two-dimensional parity check can do single bit errors or else burst errors. We have done the discussion in our lecture series, right? So based on that, we can say option C is the answer for this question. Let's move to the next question. CAPTCHA is used to provide protection from option A, zero-day attack, option B, buffer overflow, option C, automated scripted attack, and option D, man in the middle attack. So what is the answer for this question? Zero-day attack is a kind of, some flaw is being identified in the operating system of a particular vendor, but that is not identified by that vendor. That is called zero-day attack. Buffer flow is a kind of denial of service, right? Man in middle attack is while sender and receiver are making conversation, the third party person also can involve in that conversation. That is called man in middle attack. So what else remaining? Automated scripted attack, which is option C, is the answer for this question. So what is that CAPTCHA, if you can see? So generally when we are doing some mails, or else whenever we are logging into some websites, they are asking find out where is that the street light, or else where is the stops and what is the car, etc. You need to select them. So the meaning of CAPTCHA is it is completely automated. C for completely, A for automated public Turing test to tell computers and humans apart. That is what exactly the meaning of CAPTCHA. So what is the full form of CAPTCHA? Completely automated. Look at, based on this full form itself, we can tell the answer because it is automated scripted attack. So automated is there, right? So completely automated public Turing test to tell computers and humans apart. So ACHC, right? Turing test PAC. So CAPTCHA. So this way we can give the full form of CAPTCHA. Completely automated public Turing test to tell the computers and humans apart. So based on this, you can easily say option C is the answer slightly. If you know the full form of CAPTCHA, this answer is very easy. Okay, right. So look at the next question, which is given. So far whatever the questions that we have done, they're all from your ISRO 2023 paper. So look at 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So as I told you, as part of ISRO 2023, you are having 11 questions. All the 11 questions we have solved in this particular session, right? So now we are moving to 2020 questions, the next latest one after 2023. So verify, this is the question, direct question. Persistent timer, basically for what purpose we are using persistent timer in the TCP? So persistent timer is basically used for avoiding the deadlocks. So look at, to avoid the deadlock condition. Straight question, right? So which is also used for zero window size advertisements, to handle zero window size advertisements, So to handle zero window size advertisements also, we can use this persistent timer. You know that as part of the TCP, we are having 4 types of timers, like keep alive timer, persistent timer, right? Retransmission timer, time wait timer. Time wait timer we use in the connection release phase of TCP. Retransmission timer is used to recover the packet losses by doing the retransmissions. Keep alive timer is used to handle the long idle connections, and persistent timer is used to handle the zero window size advertisements, or we can also say deadlocks. So slide question it is. So here this is being used. We are using what timer? Retransmission timer. TCP retransmission timer is used here. So this is to detect the crash from the other end of the connection. This is what your keep alive timer. For this purpose, we are using keep alive timer. And to timeout, for this purpose we use a timer called time wait timer. And what else remaining? Avoiding the deadlock, that is what your persistent timer. So basically your TCP uses 4 types of timers. In its timer management, it is having 4 types of timers. What are the 4 types of timers? One is called keep alive timer. Another one is called persistent timer. Another one is called retransmission timer. And the last one is called time wait timer. These are the 4 we are using, right? This type of 4 timers we are using. So based on that, for every timer we are having their own purposes. Based on that, we can easily answer this question. Option C is the answer for this. I hope you are clear with the explanation of this question and all of you got the same answer. Am I correct or not? Right. So let's move to the next question. So this is in again 2020. Look at the question. Avalanche effect in cryptography. Avalanche effect in cryptography refers to option A, large changes in ciphertext when the keyword is changed minimally. Large changes in the ciphertext when the plain text is changed. Option C, large impact of the keywords change to length of the ciphertext, and option D, none of these. So basically, avalanche effect in the sense, if you are doing any modifications in the plain text, right? If you are doing any modification in the plain text, the impact on the ciphertext as well as the key, that defines the impact that is happening on the plain text as well as the impact that is happening on the keyword or its key according to the number of changes that you have done in the plain text, right? In the plain text, whatever the changes that you are doing, how much impact you are having on the plain text, on the ciphertext as well as on the key or its keyword, that is defining your captcha, that is defining your avalanche effect. So for this question, we can give both option A as well as option B is the answer for this question. So both are correct answers for this. Okay? Both are correct answers, A and B. So if there is any changes that you have done in the plain text, so large impact on both ciphertext as well as keyword. So these are the questions that you are having from 2020. And look at, there is one more question we are having, which is the checksum field in the TCP header. So basically, you know that checksum is we are generating by applying the ones complement. So this checksum is used, TCP is calculating the checksum for both data as well as header, and of course it is also having the pseudo header also. So overall, option B is the answer for this question. Option B. Okay. So these are some set of questions that we can discuss as part of this previous year ISRO PYQ series that is conducting by ACE Engineering Academy. And this is what the discussion from computer networks, right? I hope you are clear with all these questions and you got the idea what kind of questions that we have from the previous years, right? So all the best for your ISRO examination for all ISRO aspirants. I hope this session is helpful to you in recalling all the concepts. Thank you.